Hello everyone and welcome to this video on graphs. In this video we'll discuss the graphs of following function: lines, inverse relation graph, parabolas, logarithm, exponential and trigonometric function. So let us first start with lines. As we know, the standard equation of line is given by y is equal to mx plus c, where m is the slope of the line and c is the y-intercept. We'll first start with the line which is passing through the origin, that is the slope is 1 and the y-intercept is equal to 0. Then we'll increase the slope from 1 to 2. It will still be a line which is passing through the origin, and then we'll introduce the y-intercept as well. So let us first start with this equation: y is equals to x. So the graph for this equation will be drawn in this way. It will be along the first and the third quadrant and it will pass through the origin. If we take the second equation, the graph for y equal to minus x, it will be drawn in this way. It will be cutting across the second and the fourth quadrant. Now let's see what will happen if we increase the slope of the line. So here the slope was equal to 1. If we make the slope as equal to 2, so the equation will become y equal to 2x. So the graph for this equation, y equal to 2x, will look something like this. The line will become a lot more steeper. It will move towards the y-axis. Similarly, the graph for y equal to minus 2x, it will also become a bit more steeper and it will move towards the y-axis. So this is how these four graphs will look like. Let us now introduce the y-intercept and see how to draw the graph. So if we take the first equation, which is y is equals to x plus 1. So here the slope is equal to 1 and the y-intercept is also equal to 1. Now the graph for the equation y equal to x was drawn in this way, such that it was passing through the origin. Now what has happened due to the y-intercept? The graph will move 1 unit above. So instead of passing through the origin, it will intersect the y-axis at the point 0, 1. So this is how this graph will look like. So if you put y equal to 0 in this equation, you will get the value of x. So in this way, you can find the x-intercept also, which will come out to be minus 1. So this point, which is the point at which the line is cutting the x-axis, it will come out to be minus 1, 0. Similarly, if you take the second equation, which is y is equals to x minus 1. Again, the graph for y equal to x was passing through the origin. Now due to this y-intercept, which is minus 1, the graph will shift 1 unit downwards. So it will look something like this. It will be parallel to this line and this point will be 0, minus 1, since the y-intercept in this case is minus 1. Similarly, if you put y equal to 0 in this equation, you will get the x-intercept, which will come out to be 1. So this is how your graph for the second equation will look like. Now in the first two cases, the slope was equal to 1. If we make the slope equal to 2, your equation will become y is equals to 2x plus 1. So what will happen? Because the slope has increased, the lines will become a lot more steeper. So this equation y is equals to 2x plus 1, the graph will look like this. Again, the y-intercept is 1. And if you want to find the x-intercept, you will have to put y equal to 0. The x-intercept will come out to be minus 1 by 2. So this point will be minus 1 by 2, 0. So this is how your third graph will look like. Now let us see how to draw the graph for the next two equation. This is y equal to minus x plus 1. Just like the first two cases in which the graph for y equal to x was passing through the origin in this way, the graph for y equal to minus x will be passing through the origin in this way from the second and fourth quadrant. Now the y-intercept is plus 1. So instead of passing through the origin, it will intersect the y-axis at 1. That means it will move 1 unit above along the y-axis. So this graph will now look like this. So this is the graph for y equal to minus x plus 1. And if you want to draw the graph for y equal to minus x minus 1, the graph for y equal to minus x is this way. And since the y-intercept is minus 1, so again it will move 1 unit downward and it will look like this way. So this point will be 0, minus 1. These two lines will be parallel. They don't appear to be, but they will be parallel. And if you want to find the x-intercept, you will have to put y equal to 0. You will get the x-intercept as minus 1. So this line will intersect the x-axis at this point. So in this way, you can draw the graph for various equations of lines. Let us now see how to draw the graph for equation of line which contains modulus. Now as you can see in this equation, we have y is equals to mod x. So first of all, understand the concept of modulus. So whenever we have a modulus, if we open the modulus, we'll get two signs, plus sign and minus sign. So this equation y is equal to x will become y equal to plus x, or it will be equal to y equal to minus x. Similarly, if you open up the second equation, this will become y is equals to x plus 1, one with a plus sign and the other will be with minus sign. So this will become y equal to minus of x plus 1. If you further open this, it will become minus x minus 1. Likewise, if you open for the third equation, this third equation will become y is equals to x minus 1. This one was with the plus sign, and if you take the minus sign ahead of it, it will become y is equals to minus of this thing, x minus 1. So this will become minus x plus 1. So now let's see how to plot this graph. If we take the first equation, which is y is equals to mod x, so instead of plotting this equation, we'll plot these two equations, which is the expanded form of this modulus. Now we know how to plot the graph for equation of a line which is passing through the origin and y-intercept is 0. It is a line which is passing through the origin. Similarly, for y equal to minus x, the graph will look like this way along the second and the fourth quadrant, and it will be passing through the origin. But if you notice, this equation was y is equals to mod x. That means the value of y can never be negative. Whatever is the value of x you put, because of the modulus, it will become positive. Even if you put negative value of x, the value of y will come out to be positive. But in this graph, you can see, since this is your y-axis and this is your x-axis, the portion of the line which is below the x-axis, in this portion, y is coming out to be negative. Hence, we'll have to erase this portion. So the actual graph for the equation y is equals to mod x will just be this, a v. Let us plot the second equation. Y is equals to mod of x plus 1. So instead of this, we'll plot these two equations. Y is equals to x plus 1 and y is equals to minus x minus 1. The graph for the equation y is equals to x plus 1, it will be a line which will, instead of passing through the origin, it will be shifted 1 units above. It will look something like this. And for the next equation, which is y is equals to minus x minus 1, it will be along the second and the fourth quadrant, and it is shifted 1 units downward because the y-intercept is minus 1. So instead of passing through here, it will pass through this point. Now again, in this case also, as you can see, the value of y will always be positive because this entire thing is in the mod. We have y is equals to mod of x plus 1. So we'll have to delete all the portion which is below the x-axis, since in this portion the value of y becomes negative. So this will be your graph. So this will be your graph for the equation y is equals to mod of x plus 1. Similarly, we can plot the graph for y is equals to mod of x minus 1. Let us see how it is to be done. We'll plot the graph for y is equals to x minus 1, and we'll plot the graph for y is equals to minus x plus 1. Now the graph for y is equals to x minus 1, the y-intercept is negative, so this graph will be shifted 1 units downward. It will look something like this. And the graph for y is equals to minus x plus 1 will be, so this will be shifted 1 units upward. Along the second and the fourth quadrant, 1 unit upward. So this will be like this. Again, in this case as well, the value of y can never be negative since this entire thing is in the modulus. So we'll have to delete all the portion which is lying below the x-axis. So this is how your graph for y is equals to mod of x minus 1 will look like. Let us see some more variations of this modulus. So if we have this equation y is equals to mod of x plus 1, the difference between this equation and the above equation is that in the above equation, this entire thing was in the mod. It was mod of x plus 1. Even this 1 was within the mod. But in this case, this 1 is outside the mod. Only the variable x is within the mod. So if we open this mod, we'll get, for the first equation, we'll get y is equals to x plus 1. 1 with a plus sign. And this thing will become minus sign. So the minus sign will only be applicable to the part which is within the modulus. So this will become minus x and this plus sign will remain as it is. So this was the expanded form for the first equation. If we take the second equation, which is this one, we'll get y is equals to x minus 1, and we'll get y is equals to minus x minus 1. So let us first plot the first two equations. For the first equation, y is equals to mod of x plus 1, we'll plot these two lines. So the first equation, which is y is equals to x plus 1, it will look like this. So this is your line, y is equals to x plus 1. And the second equation, which is y is equals to minus x plus 1, so y is equals to minus x is like this way, and it is shifted 1 unit upward, so it will look like this way. Now if you notice in this equation, y is equals to mod of x plus 1, the minimum value of y that can be is equal to 1. It does not matter whatever value of x you put. If you put x is equals to minus 100 also, the value of y will become 99. If you put x is equals to 0, the value of y will become equal to 1. If you put x equal to 99, the value of y will become 100. So the minimum value that y can take will always be equal to 1. So even if you put negative values of x, because of this modulus, it will become positive and the value of y will increase. But in this graph, as you can see, this point is the y-intercept, so the coordinate of this point will be 0, 1. As you can see, the y-intercept in both the cases is 1. So since the value of y can never go below 1, so we'll have to delete this portion which is below this point. So your graph for this equation, y is equals to mod of x plus 1, will look like this. Let us now plot the second equation, y is equals to mod of x minus 1. So in the expanded form, it will look like y is equals to x minus 1 and y is equals to minus x minus 1. So the graph for y is equals to x minus 1 will be shifted 1 unit downward. So it will look like this. So this is your graph for y is equals to x minus 1. And the graph for y is equals to minus x minus 1, minus x minus 1, again shifted 1 unit downward. So it will look like this. So this is your graph for y is equals to minus x minus 1. Now again, if you see in this equation, the minimum value that y can take will be equal to minus 1. It can never go below minus 1 because whatever value of x you put over here, because of the modulus sign, it will become plus and then the value of y will increase. So if you put x equal to 0, you will get y is equals to minus 1. So we'll have to delete all the portion of the graph which is below this point, since this is the y-intercept, which in this case is 0, minus 1. As you can see, the y-intercept for both this line is minus 1. So we'll have to delete all the portion which is below this point, that is these two portion. So we will get our graph as this. So this will be your graph for the second equation, y is equals to mod of x minus 1. Let us now see how to plot the graph for the third equation, which is y is equals to mod of mod x minus 1. So we have two mods over here. So we'll plot this graph separately. We have y is equals to mod of mod x minus 1. So we'll have to open two mods. So when we open the outer mod, we'll get the equation as y is equals to mod x minus 1, and the second equation will get y is equals to minus of mod x plus 1. Because of the minus sign, this minus will become plus. Now if you open the second mod, we'll get two more equation, which will be x minus 1 and minus x minus 1. Similarly, this equation will become minus x plus 1, and because of the minus, this minus and minus will become plus, we'll get x plus 1. So now we'll have to plot these four graphs to get the graph of this equation. So let us plot them one by one. So the first equation, which is x minus 1, the graph will look like this, shifted 1 unit downward. So this is how your first equation will look like. Let's plot the second equation, which is minus x minus 1. So again shifted 1 unit downward. It will look like this. Let's plot the third equation, which is y equal to minus x plus 1. So minus x plus 1. So this portion will be shifted 1 unit upward. So it will look like this. Similarly, the fourth equation, y is equals to x plus 1. It will be shifted 1 unit upward. It will look like this. Now if you notice, this entire thing is within mod. So the value of y can never be negative. So we'll have to delete all the portion which is below the x-axis. So we'll have to delete this portion, this portion, this portion, and even these two portions. Now since these two are the overlapping part, we'll remove them. And finally, we'll be left with this graph. This is your graph for y is equals to mod of mod x minus 1. So this is all about lines. Let us take our next function, which is the inverse relation. Now if you notice in this function, the relationship between y and x is such that if x increases, the value of y will decrease. Hence this function is called as inverse function. If the value of x decreases, the value of y will increase. So let us see how to plot this graph. If we take the first graph, y is equals to 1 by x. So with increase in x, the value of y should decrease. So this is your y-axis, this is your x-axis, this is your negative y, and this is your negative x. So with increase in x, the value of y should decrease. So your graph will look like this. So as x is increasing, y is coming down. So this was in the first quadrant. We can draw a similar graph in the third quadrant as well. With increase in the value of x, as x is increasing, that is, it is moving from negative to positive side, the value of y is decreasing. It is becoming more and more negative. So this is how your graph for y is equals to 1 by x will look like. Let's take the next equation, which is y equal to minus 1 by x. So now your graph for y equal to minus 1 by x. Now because of this minus sign, due to increase in x, y value will also increase. But since it is an inverse graph, we'll draw it like this way. So with increase in x, your value of y is also increasing. So as x is increasing, it is moving from negative to positive. The value of y is also increasing. Similarly, in the fourth quadrant, we can draw it like this way. As x is increasing, your value of y is also increasing. It is moving from negative to positive. Now let's see what will happen if we increase the coefficient from 1 to 2. The only difference will be these graphs will move away from the origin. So the graph for y equal to 1 by x was this way. So the graph for y equal to 2 by x will be further away from the origin. So these two will represent the graph for y equal to 2 by x. Similarly, the graph for y equal to minus 2 by x, it will look like this. It will move away from the origin. Let us now introduce the modulus in this graph and see how it is to be drawn. So if we consider this graph, we have y is equals to mod of 1 by x. So if we open the mod, we'll get y is equals to plus 1 by x and y is equals to minus 1 by x. Now if you notice, the value of y can never be negative. We know the graph for y equal to 1 by x will be drawn in the first quadrant and the third quadrant. In the first quadrant, it will look like this way. In the third quadrant, it will look like this way. But in the third quadrant, the value of y will become negative. This is your negative y-axis. So we will not consider this graph. We'll delete this portion. So we'll just draw the graph in the first quadrant. Since in this quadrant, the value of y will be positive. So if we consider the second graph now, y equal to minus 1 by x. In the second quadrant, the graph will be like this way. Y equal to minus 1 by x. Again, in the fourth quadrant, the graph will look like this way. But in the fourth quadrant, the value of y will become negative. So we'll not consider this. We'll delete this thing. So this will finally represent your graph for y equal to mod of 1 by x. Let us now consider the third function, parabola. Now the standard equation of parabola is represented as y is equals to x minus h the whole square plus c, where c represents the position of vertex along the y-axis and h represents the position of the vertex along the x-axis. So this is your y-axis, this is your positive x and negative x-axis. So what we will do is we'll first plot the graph of parabola having the vertex at the origin. That is, the value of h will be equal to 0 and c will also be equal to 0. So your graph will become y is equals to x square. Now one thing to note here is your y in this case is your dependent variable and x is your independent variable. So when we have equation in this form, y is equals to x square, then this parabola will be symmetric about the y-axis, about the dependent variable axis. Likewise, in the third case, the equation is in the form of x equal to y square. So your parabola will be symmetric about the x-axis. And one last point before we draw the graph. Whenever the coefficient of the independent variable is positive, then your parabola will open along the positive direction of your dependent variable axis. In this case, y is equals to x square. Your coefficient is positive, so your parabola is symmetric about the y-axis and it will open along the positive direction of y-axis. That is, it will open upwards. Whereas in this case, your coefficient of independent variable is negative. We have y is equals to minus x square. This graph will now be symmetric about the y-axis. It will be symmetric about the dependent variable axis. And because of this negative, it will open in the downward direction. That is along the negative y-axis. So let us see how to plot this graph. If you take the first equation, which is y equal to x square. So this is the parabola which is passing through the origin. H is 0, C is 0, and it is positive. Since it is in the form of y equal to x square, it will be symmetric about the y-axis. And because it is positive, it will open upward. So your graph will look like this. So this is your graph for y equal to x square. So if you want to plot the graph for y equal to minus x square, because of this minus, this parabola will now open in the downward direction. It will just be the mirror image of this graph. So it will look like this, with the vertex at the origin and opening downward. It is symmetric about the y-axis. Now let's see how to plot the next two graph, x equal to y square. Now your dependent variable is x-axis, so your parabola will be symmetric about the x-axis, and it is positive, so it will open along the positive direction of the x-axis. So your graph will look like this. So this will be your graph for x equal to y square. For x equal to minus y square, your parabola will open along the negative x-axis, or it will be the mirror image of this graph. So it will look something like this. So this is your graph for x equal to minus y square. Let us now one by one introduce the variable h and c. So as I have discussed previously, c represents the position of the vertex along the y-axis and h represents the position of vertex along the x-axis. Let us see how to plot this graph. So let us take the first equation, which is y is equals to x square plus c. Now we have seen how the graph of y equal to x square will look like. It will be a graph which is passing through the origin and opening upwards, symmetric about the y-axis. Now because of this plus c, your vertex instead of lying at the origin will move c units upward along the y-axis, since it is plus c. And in the second equation, if you will see, it is minus c. So what will happen? Your graph will still be the same. It will be symmetric about the y-axis. The coefficient of x is positive. It will still open along the positive direction of y-axis. But because of this minus c, the vertex of the graph will move c units downward. So let us see how to plot them. So for the first equation, y equal to x square plus c, it will look like this. Your vertex has been shifted c units upwards. So the coordinate of this point will be 0, c. For the second equation, y equal to x square minus c, your vertex will, instead of going c unit upward, it will go c unit downward. So your graph will look like this. So the coordinate of this point will be 0, minus c. Let us see how to plot the third and the fourth graph. So h, as I have said, it represents the position of vertex along the x-axis. Now the standard equation for the parabola was y is equals to x minus h the whole square plus c. So let's see what will happen in case of y is equals to x minus h the whole square. We know the graph of y equal to x square will be opening upwards, symmetric about the y-axis and passing through the origin. But because of this minus h, it will now move h unit towards the right hand side. That is along the positive direction of x-axis. Notice, in case of plus c, it was moving along the positive direction of y-axis. Because of minus c, it was moving along the negative direction of y-axis. But because of minus h, it will shift along the positive direction of x-axis. And because of this plus h, it will shift along the negative direction of x-axis. So this is a minor difference between plus C and plus H that you need to take care. So if you plot this equation, y is equals to x minus h the whole square, your vertex will shift h unit along the x-axis. So your graph will look like this. So your coordinate of this point will be h comma 0. And if you plot the fourth graph, it will be y is equals to x plus h the whole square. Because it is plus, it will move h unit along the negative direction of x-axis. So your graph will look like this. So the coordinate of this point will be minus h comma 0. So if you are able to understand these individual movements because of plus c and minus h, you will not face any problem in plotting the graph for combined movement. So in this equation, as you can see, we have the graph for y is equals to x minus h the whole square plus c, x minus h the whole square minus c, and so on. So we have both the movement, that is movement along the x-axis and movement along the y-axis. So let us see how to plot this first equation. Y is equals to x minus h the whole square. So it has moved h unit along the x-axis and c unit along the y-axis. So your graph will look like this. And the coordinate of this vertex will now be h comma c. If we take the second equation, we have y is equals to x minus h the whole square minus c. So again, it has moved h unit along the positive direction of x-axis, but c unit along the negative direction of y-axis. So we'll have the graph is like this way. So the coordinate of this point will now be h comma minus c. Similarly, if you plot the third equation, we have x plus h the whole square plus c. So it has moved h unit along the negative direction of x-axis and plus c unit along the y-axis. So we'll have minus h comma c as the coordinate of this vertex. Similarly, for the fourth equation, we have y is equals to x plus h the whole square minus c. So your graph will look like this. So this point will now be minus h comma minus c. So this is how you can plot the graph which involves both the combined movement along the x direction as well as y direction. Now in this case, we have considered the coefficient of the independent variable as plus. So what will happen in case we have minus sign over here? So we'll get the mirror image of the respective graph. So instead of y is equals to x minus h the whole square plus c, if we had y is equals to minus of x minus h the whole square plus c this way, it will just be the mirror image of this graph. Likewise, you can consider for the third and the fourth case as well. Let us now see how to plot modulus graph in case of parabola. So let us consider this first equation, which is y is equals to mod of x square minus c. So again, as with mod, what we'll do is we'll first open the mod. We'll get two equations. Y is equals to x square minus c, and the next equation will be y equal to minus x square plus c, and the entire value of y should always be positive. So let us plot these graphs one by one. Y is equals to x square minus c, so it is symmetric about the y-axis. It is opening along the positive direction of y-axis and shifted c units downward. So it will look like this. So this will be your graph for y equal to x square minus c. If we plot the second graph, which is y equal to minus x square plus c, it is symmetric about the y-axis. Now because of this minus sign, it will be opening downward and shifted c unit upward. So this will look like this. So this is how your second graph will look like this. But overall, we need the value of y to be positive. So we'll have to delete all the portion of graph which is below this x-axis, because below this x-axis the value of y will become negative, and for this equation the value of y can never be negative. So we'll have to delete this portion, and this portion. So this is how your graph for the first equation will look like. Now for the second equation, the only difference is that we have added h to the x. So we have the equation mod of x plus h the whole square minus c. So because of this plus h, what will happen? Your shape will look like this, only that it will shift h unit towards the left hand side. So this entire graph will shift h unit towards the left hand side. In this case, the coordinate of this point is 0 comma c. So for the second case, the graph will look like this. and the coordinate of this point will be minus h comma c. Likewise, for the third case, the graph will shift h unit towards the right hand side. So your graph will look somewhat like this. And the coordinate of this point will now be h comma c. Now if we consider the fourth equation, which is y is equals to x square plus c, it is in mod. So once we open the mod, we'll get x square plus c and we'll get minus x square minus c. Now focus on the second part, y equal to minus x square minus c. It is symmetric about the y-axis. Because of this negative sign, it will open in the downward direction. And because of minus c, it will be shifted c units downward. So your graph will look like this. But if you notice, this entire thing is in mod, so the value of y can never be negative. So this second part will actually be redundant. We don't have to draw the second part because this entire graph is lying below the x-axis, in which the value of y is always negative. So what we will do is we'll just draw the first part, that is y equal to x square plus c, and the graph for y equal to x square plus c will look like this. This will be your graph for this equation, y equal to mod of x square plus c. Let us move ahead and see how to draw logarithmic graph. So this is a simple logarithmic equation, y equal to log x. So the graph for y equal to log x, this is your y-axis, x-axis and negative x-axis. So the graph for y equal to log x will look like this. So let us find what will be the coordinate of this point. As we know, log of 1 is equal to 0. So if you put 1 over here, the value of y will become equal to 0. So at x equal to 1, y will be equal to 0. So where is y becoming equal to 0? At this point, y is becoming equal to 0. So what will be the x coordinate of this point? It will be equal to 1. So the coordinate of this point will be 1 comma 0. Let's see now the second equation, y equal to log of 1 by x. So this graph will be plotted in this way. So this is how your graph for the second equation will look like. Again, the coordinate of this point will be 1 comma 0, because if you put x equal to 1, this will become log 1 and log 1 is 0. So the value of y will become equal to 0. So the coordinate of this point will be 1 comma 0. Let us now see how to plot the third equation, which is y equal to log of x plus 1. So in this equation, if we put x equal to 1, what we'll get? This part will become log of 1, log 1 is 0 and plus 1. So the value of y will become 0 plus 1, which is 1. So at x equal to 1, your value of y will be equal to 1. So this is a logarithmic graph. So at x equal to 1, which is this point, y will also become equal to 1. So your graph must pass through this point. So your graph for this equation will look like this way. Like this way. So this is how your graph for the third equation will look like. It has just shifted a little bit and the coordinate of this point will be 1 comma 1. Let us see the second case, in which we have to plot the graph for y equal to mod of log x. So once we open the mod, we'll get y equal to log x and y equal to minus of log x. So if we plot the first equation, which is y equal to log x, your graph will look like this. For the second equation, y equal to minus of log x. So now this minus sign we can take into the power. This will become log of x raised to minus 1. So this will become log of x inverse. X inverse can be written as log of 1 by x. So we'll have to plot y equal to log of 1 by x. Now the graph for y equal to log of 1 by x will look like this way. So this will be your graph for y equal to log x. Now if you notice in this equation, the value of y can never be negative since this entire thing is in mod. So we'll have to delete all the portion of the graph which is below this x-axis. So we'll have to delete this portion, we'll have to delete this portion. We'll only keep this portion and this portion. So we'll delete this portion. We'll be left with this. This will be your graph for the equation y equal to mod of log x. Let us now see how to plot exponential graphs. So these are your exponential equation. Y equal to e raised to x. The graph for y equal to e raised to x, it will look like this. So this will be your graph for y equal to e raised to x. For y equal to e raised to minus x, your graph will look like this. This will be your graph for y equal to e raised to minus x. Now what will be the graph for y equal to minus of e raised to x? It will be the mirror image of the graph y equal to e raised to x. So the mirror image of this graph y equal to e raised to x will represent the graph of y equal to minus e raised to x. So it will look like this. So this will be your graph for y equal to minus e raised to x. Similarly, the graph for y equal to minus of e raised to minus x will be the mirror image of, so it will look like this. So this will be your graph for y equal to minus e raised to minus x. Now let us focus on this point. So what will be the coordinate of this point? So if we put x equal to 0, so this will become e raised to 0. Anything raised to 0 will always become equal to 1. So at x equal to 0, the value of y will be 1. So at this point, the value of x is 0. So the value of y will become equal to 1. So the coordinate of this point will be 0, 1. Similarly, if we put x equal to 0 in this point, we'll get the value of y as minus 1. So the coordinate of this point will be 0, minus 1. Let us now see how to plot the fifth equation, which is y equal to e raised to x plus 1. So if we put x equal to 0 in this equation, what we'll get? This portion will become equal to 1 and this is 1. So the value of y will become equal to 2. So what will happen? Your graph will shift upwards. So it will look like this. So the point at which your graph will cut the y-axis will be 0, 2. So this will be the coordinate of this point. Let us now introduce modulus in this graph and see how to plot this. So in this graph, we have to plot y equal to e raised to mod x. So when we open the mod, we'll get y equal to e raised to x and y equal to e raised to minus x. The graph for y equal to e raised to x, it will look like this. And the graph for y equal to e raised to minus x, it will look like this. So this will be your graph for y equal to e raised to minus x. Now for this graph, y equal to e raised to x, we'll have to take the common portion. So we'll delete the portion which is below. So we will delete this portion and this portion. So your graph for y equal to e raised to mod x will look like this. And the coordinate of this point will be 0, 1. Let us now see how to plot trigonometric graph. So there are three important functions that we need to plot: y equal to sin x, cos x and tan x. So the graph for y equal to sin x, it will look like this way. And it will also extend along the negative direction of the x-axis. So this is how your graph for y equal to sin x will look like. At this point, the value of x will be equal to 0. At this point, the value of x will be equal to 90 degree or pi by 2. At this point, it will be 180 degree or pi. At this point, it will be 270 degree or 3 pi by 2. And at this point, your value of x will be equal to 360 degree or 2 pi. So in this way, one cycle will be completed. So this is your one cycle for the value of sin x. And then after this, your cycle will repeat again. So this will go on and on in this fashion. For cos x, your graph will start from this point and it will look like this way and it will go on and on. Similarly, it will extend on the negative direction of x-axis as well and it will look like this. Again, this point will represent 0. This will be pi by 2. This will be pi, 3 pi by 2, and this will be 2 pi. So at this point, your cycle will get completed and then it will keep on repeating. Let us now see how to plot y equal to tan x. Your graph for y equal to tan x will look like this. So this is how your graph for y equal to tan x will look like. It will just keep on repeating. In similar way, we'll have along the negative direction as well. So in this way, you can plot the graph for trigonometric function. I hope you were able to understand these concepts of how to plot the graph, and you will not face any difficulty in solving problems based on graph. So in the next video, we'll solve some problems based on graphs. Thank you.